Welcome back. Today we're going to talk about cubic functions and cubic root functions. Okay, the first one we're going to talk about is a cubic function where you have x cubed. So you're taking a base and you're essentially multiplying it by itself 3 times. So here, if I take negative 2, what I would end up doing is actually getting negative 8, because negative 2 times negative 2 times negative 2 gets me, this would be positive 4 times negative 2, which is negative 8. So notice, unlike the square root function, or unlike the squaring function, which only gets positive numbers, the cube root gets negative numbers. So negative 2 cubed is negative 8, negative 1 cubed is negative 1, 0 times 0 times 0 is 0, 1 times 1 times 1 is 1, and 2 times 2 times 2 is 8. Okay, so let's go ahead and plot these. Negative 2, 8 is here. Oh, this is actually going, this 2, 4, 6, 8. So this is going by 2s. So negative 2, negative 8 is here. Negative 1 is here. 0, 0 is here. 1, 1 is here. And 2, 8 is here. So what you'll notice is it actually makes this shape, this S shaped. And it's really good to memorize what shape things come in so that it's easy to sort of, I knew that it was going, that these points when connected would create this sort of, to me it looks like an S, this sort of stretched out S shape, because I've seen this before. Okay. The domain for this function is all real numbers. It's defined for all real numbers, and the range is actually all real numbers too. Unlike the quadratic equation, which only gets you positive numbers, the range for the cubic function is all real numbers. Okay, now some common transformations. If I take this negative x right here, what it's going to do is it's going to, so remember, a negative is a reflection over the x-axis. So this is the original cubic function. What it will do is it will reflect each part. So this branch will reflect over the x-axis to get something that looks like this. This branch will reflect over the x-axis to get something that looks like this. So I'm doing a horrible job at drawing this, but it looks something like this right here. So if I were to go ahead and graph it so you can see it, you would have negative x cubed. So here you're going to have to go ahead and do this right here. And here it is, right? So the original one was an S, and then each branch will reflect over the x-axis to get this one. Okay. This next one is a horizontal shift left of 4 and a vertical shift right of 1. So here, a vertical shift up 1. So here, if I go like this, let's see, I'd want to go in parentheses x plus 4, and then I'm going to cube that, and then I'm going to arrow to the right so that I'm down on the main line right here and put plus 1. Okay, and if I graph it, you'll see that the S shape has been shifted left by 4 and then up by 1. Okay, what usually goes through the origin is this point, so it's been shifted. You can see it's up by 1 and left by 4. Okay, so it follows the same shifting patterns that we've seen before in other functions. Okay, now we're going to switch it up now. Instead of talking about the cube function, we're going to talk about the inverse function, which is the cubic function, or the cubic root function. So here we're not cubing something, we're taking the cubic root of it, okay, or the cube root of it. So essentially we're taking the input like this x right here, and we're asking ourselves what number that when we represent it 3 times as a factor, does it multiply out to negative 8? So essentially the cube root of negative 8 is going to be negative 2. Now unlike the square root function, which only takes in positive numbers, the cube function takes in negative numbers. And we've seen this before at the very beginning of the year. So this right here is negative 2. The cube root of negative 1 is negative 1. The cube root of 0 is 0. And then you have 1 and 2 right here. Okay? So essentially it just takes the input of the cubic function and switches it around. Okay? So here we have what's now on the x-axis, negative 8, only goes to negative 2 on the y. Then negative 1 would be here. 0, 0 would be here. 1, 1 would be here. And 8, 2 would be here. Okay? So here, this is the cube root function. Now what you're going to notice is it actually looks a lot like the cubic function. It's actually been reflected over this line. Y is is equal to x right here. This one and this one. So what used to be the cubic function, which was, it went up as an s like this blue, whoops, down like this, it's been reflected over this straight line, y is equal to x. And remember, that's what happens with inverse function. It's reflected over that to get this, this red S shaped, and that's a cubic function. Now, in order to get that on your graphing calculator, let's go here and clear this out. So we would go to Math, and the cubic root is option 4. So the cubic root of x, okay? And it's nice, it puts the this 3 in as an index of your radical here. And we go ahead and graph that, and you'll see it's just like this S shape that we talked about, right? Has this little like curve as it goes to the origin here. Now the domain of this function, so essentially what can I put into the x here? The domain of the cubic root function, or the cube root function, I keep saying cubic, but it's actually cube root function, is very nice. It's actually all real numbers. It's unlike the square root function where the domain is only values that make the expression under the radical positive. This one's all real numbers, and the range is actually all real numbers too. Okay. And actually, let's talk about the end behavior real quick. So as x goes to infinity, y also goes to infinity. Okay, so you can see here it goes to infinity. It's a little strange to say that because it actually grows very, very small, just like the square root function, but it does go to infinity. And as x goes to infinity, y goes to negative infinity. You can see this branch is starting to go, it gets lower and lower and lower. It just decreases slowly. Okay, now let's talk about the transformations. So here we see a 3 on the outside. And remember, a number that's on the outside is going to stretch it. So it's going to essentially make the y values get bigger. So it's when we had two parabolas, it looked like people grabbed the ends of the parabolas and stretched it up towards the y-axis. For us, it's going to separate the s a little bit more away from the x-axis. So here, essentially, you just take all your old outputs. This was for f of x. Let's just write this here. For f of x, I had -2, -1, 0, 1, and 2. It's just going to multiply those all by 3. So it's going to be -6, -3, 0, 3, and 6. So here's the old f of x function. Let's just go ahead and graph the g of x, what they're calling it now. So you have -2, -6 here. You have let's see, -1, -3, so there's actually, yeah, okay. This one's going by a different scale. So you have -1, -1, 2, 3 right here. 0, 0, so it still passes through the origin. And then 1 and 1, 2, 3 right there. And then you have, whoops, this should actually be, I graphed this point wrong. This should be -8, -6, which doesn't even show here, right? So we'll just start with this. And so what this looks like is like this. So it's going to start curving off like this and down like this, okay? So essentially it's just taking the branch and stretching it away from the x-axis. Again, if you're having trouble visualizing it, just go ahead and put it in your graphing calculator. Let me do a second insert here so that I can put a 3 in and go ahead and graph it. You'll see it just stretches it away from it. Remember, after you graph it, you can always use your table to come up with values. Okay. Let's try one more transformation here. So essentially, this is taking 1/2 of all the values before, and what we saw. So usually, what it does is it smushes the function down towards the x-axis. That's going to be the same as what we're going to see here. So this s is going to be on the inside of the s that we already created. It's going to be taking these branches and smushing it down towards the x-axis, basically flattening it or compressing it. So here it just takes all the old values, which was -2, -1, 0, 1, and 2, and it multiplies them by half. So -1, -0.5, 0, 0.5, and 1. Okay, and I'm going to let you go ahead and graph this on your graphing calculator here. Let me actually just graph it like here. So if I go math and option 4 here, and I put x in, but I was supposed to put at 1/2 here. So let me go ahead and go second insert. Oh, that actually gets me to my index. So second insert, and I want to go alpha y equals to insert 1/2 here as a stack fraction, so 1/2. Okay, and let's go ahead and graph that. So the first thing that comes up is the one that you just saw. This is the second one. It's a little harder to see that it's actually making an S. If you want, you can change the window so that the values of x are even smaller. So let's say, or let's make the values of y smaller here. Let's say we want it just between, it's basically zooming in on the y-axis. Let's just say -4 and 4. And then we'll be able to see the second one a little bit better. So this was the one with the 3 in the front, and this is the one with the 1/2 in the front. So essentially it does have that little S shape right there, but essentially it just took the two branches and flattened them towards the x-axis. Makes them grow even less fast. Okay, so you can go ahead and graph that. I'm not going to take the time to do it right here. We have, I believe, 2 more. So we have some vertical shifts and horizontal shifts. So here you have a horizontal shift to the right by 2, right? So what used to be the origin is now at 2, 4. So what used to be the origin is now at 2, 4. So 2, 4 right here. This whole thing, so there's no number on the outside here. So it's like taking this S shape. It's actually, this is a trick that I can use. You can't use it. But it's taking this whole S and like moving it up like this, right? Because there's no vertical compression or stretch. So it's just taking the original shape and moving it up. And I'm going to go ahead and let you fill in these values. So here it looks like it's being graphed between -6 and 10. And you know what? I lied. Let me just go ahead and do this. So if I put -6 in here, -6 minus 2 is -8. The cube root of -8 would be -2 plus 4 would be 2. So at -6, it's at 2, which is essentially what you can see here. At 1, you would have 1 minus 2, which is -1. Cube root of -1 is -1. -1 plus 4 is 3. So you'd have 1, 3 here, okay? And then 2 would be 0. Cube root of 0 is 0 plus 4 is 4. This would be 1, 1. Cube root of 1 is 1 plus 4 is 5. And 10 minus 2 is 8, cube root of 8 is 2, 2 plus 4 is 6. Okay, so they actually chose some values of x here that were pretty optimal for you because it created integer values for y. But you can see it's just the same as what we've been talking about in terms of vertical and horizontal shift. And you're going to see this again and again. Like this is a repeating feature of discussing functions. You look at the parent function, you sort of memorize some characteristics of the parent function, what it looks like. Some of the, right here, it starts the curve. Usually the parent function has a curve, a branch that goes up like this and another branch that goes down like this. And the change between those two branches occurs at the origin. And so all you do with other transformations is you take that change and you just move it around. And then you compress the shape or you stretch it. Stretches, it goes away from the x-axis. Compressing it means it presses it towards it. Okay, let's just try one more thing. So here, let's see, our origin essentially is at -3, -2. And again, I know I'm going pretty fast with this, but you've already seen these transformations before. And if you can't remember them, then you can go back to the transformations on the quadratic function. So it's essentially, there's no, oh, I thought there was a reflection there. There's no shift here, so, or there's no compression or stretching, so you just take the parent function, grab it, and let's see, we're going left by, whoops, the branches didn't stick together, so let me just make sure these are together by grouping them. So I go left by, let's see, 1, 2, 3 right here, and down by 2. So essentially this would go like this, okay? And you can go ahead and put these in. Again, they're choosing optimal values here. That gets you -8, which essentially gets you -4 right here. You could just graph them on the graphing calculator if you want to pick up these values. We've seen these all before, right here. So you would do math, option 4, cube root of x plus 3, and then on the outside -2, and there it is. Okay, so just like I said, it was left by 2, left by 3 and down by 2. As you see, left by 3, down by 2 right here. And if I go to my table, then I can just go ahead and pick off the values that they want here. If they're asking you to fill a table in, pretty easy, negative 11, 4, and then I would go to negative 4. That's probably another integer value there. And so just fill in the table and plot the points. But what's essential is you know that what's happening here is it's vertical or horizontal, vertical compression or stretching, and then the horizontal and vertical shifts. And that's it. We've just used our discussion of transformations that we've done before in order to discuss the parent function of the cubic function and the cube root function in order to graph them. And that's the end of the lesson for today.